All right, welcome everyone, and welcome to Common Cache Issues in 2023. I don't know if anyone here has attended some of our previous talks, but we love talking about cache misses and caching issues in Gradle builds. So to kick it off, I'm Nelson Osacky. I'm lead solutions engineer at Gradle. I have some previous experience as an Android as an Android developer. Actually, a lot of experience. I used to work at Square, at SoundCloud, and other Android companies, and now I work at Gradle, helping customers improve their Gradle builds. And I'll talk a little bit more about what we do on the solutions team in the next slide. Inaki, you want to introduce yourself?
Yeah, Inaki Villar. I'm a solutions engineer in Gradle Enterprise, and previously I was working in Tinder and Agoda and some of their companies, always focus in Android development.
And Inaki is the master cache miss reproducer. He can reproduce any cache miss issue or customer bug. It's amazing. So yeah, a little bit of what we do on the solutions team, because I think most people here are Android developers. So yeah, just to explain our role. On the solutions team, we work with customers, prospects, open source partners to optimize their build performance, reduce errors, and generally help them out in whatever they need. We also report issues internally and with partners like JetBrains, Google, other open source partners, and other open source projects. And we also go in and fix those issues. If it's, for example, an open source plugin on GitHub, we'll submit a pull request. And then we also work on tools to improve the customer experience, scripts, samples, code like that. And if you want to see all our open source partners, such as Android X, we have Spring, we have Detect up there. We give them a free Gradle Enterprise instance, and you can see all their builds. So check out that link at the bottom. Yeah.
Okay, so yep. If we need to maybe simplify the things and try to put like a formula of what is work, we can say that work is equals effort plus time. If we are talking about the bills, the effort is the consumption of resources, of course. But the effort, I would say that as well is the energy that we are spending. So imagine that you are at your office or maybe, well, in your home. You're working with Android Studio, doing these awesome features. And right to you, there is a bookshelf with different books, references that you are using in your daily work, like effective Java, well, I hope that not, but TCP/IP, and so on. So, and let's think, this is just an example, that every time that you move to the bookshelf, you are spending 1 step and 1 second. So if I need to retrieve the programming Android with Kotlin, I'm going to spend 3 steps plus 3 seconds. But well, so we are in 2023, so that means that we need to use Compose, right? So if I need to check the Compose book, I'm going to spend like 5 seconds and 5 steps. So one of the first optimizations that we can think is trying to move the book that I'm going to check often right, well, close to my desk, right? In this case, I'm developing a composable function. I need to check often this book. So that means that I'm reducing the time where I'm spending to do this work. So just 1 step and 1 second. And actually, this approach is one of the basics of one of the data structures that we are using everywhere. But we can go more, well, further and trying to do another optimization. And instead of going to the bookshelf, I'm going to create an abstraction that is close to my desk that contains the book that I'm using. And that is what is caching. So in this case, I'm going to reduce more the work that I need to do in terms of taking the Jetpack Compose specifications. And again, caching is the most simple and effective way to optimize the build and optimize the work. We can create different abstractions like different kind of caches. We can have one local cache and one remote cache. Actually, this is how works Gradle. And the best thing is that we don't need to understand anything about the implementation details of caching. We are just clients, consumers of the cache. Our only responsibility is to keep the integrity and consistency of the cache request. For instance, here we have in the local cache the domain-driven design, and in the remote cache the same book. Actually, a very good book. So if from my desk I'm requesting the domain-driven design that we have in the cache, but the third edition is going to generate a cache miss because the book that I have in the remote and local cache is the second edition. So that's why I was saying that our responsibility is trying to keep the integrity of our request. So we need to check that, or we need to check what the same edition in this case. Okay, moving to Gradle. A task is the basic unit of work of Gradle, and a task generates an output. Imagine the Kotlin compiler is going to generate a class, a bytecode class. At the same time, a task can have different inputs. For instance, the file source actually is an input of the Kotlin compiler. Some of the arguments of the Kotlin compiler that are going to be used by the task. So, given input, a task is going to generate an output. And the theory says that if the inputs are the same of the ones that previously have been calculated, we can reuse the output. And that's where comes the magic of Gradle. So the build caching on Gradle is at the level of the task, not at the level of the build. We can reuse outputs when we apply a clean in our projects. We can reuse the outputs when we switch branches. And we can reuse the outputs of other environments like Linux or other builds. And sometimes when we are talking about caching, right, we are always focusing in times, right? Well, with cache is faster, but I want to give you some insights about other benefits of caching. So first, this is the deck, one public repository about static tools. And here we're applying assemble. So we are analyzing the Gradle process and the Kotlin process without caching. So far so good. And now we are going to repeat the same, but with caching. So you see that how the pressure of the Gradle daemon has been reduced. And what is most interesting part is that we didn't spawn a new Kotlin process. So the benefits of caching is not only about time, it's about performance resources in your machine. And then let's move to Android. So of course, the particularity of Android is that we are using different plugins. The plugins are using different tasks, and we are not working with one project only, right? We have massive modularized projects. This is a project dependency graph of the Now in Android, the Google repository, and I want to highlight the importance of caching. So one of the bottom models that is called core model that contains some model, imagine that the Kotlin compiler is having a non-deterministic output for the task, meaning that every time that I'm compiling this class, I'm generating a different output. So that means that I'm going to affect all the different models and dependencies on the build. And this is the worst case scenario. That's why the problems that you can have in caching in the Android projects needs to be scaled with the number of models. So let's do the same exercise as before, but with the same project. Now we have Now in Android, Gradle assemble, Gradle process, and Kotlin process. So far, so good. When we are using caching, look that the Gradle daemon, even though we have the same scale, we have reduced the usage of the heap and the max allocation of the heap memory. And again, what is better is that the Kotlin process is not executed. So overall, in this build with caching, and we don't do anything, we are reducing by 60% the performance required to run the build. It's not about timing.
All right, so since we're going to talk a lot about cache misses in this presentation, uh, let's talk about what a cache miss is. A cache miss means that the cache key is different for a task in a way that you didn't expect. And oftentimes this is caused by absolute paths. For example, if you run a build on one machine and your user home directory includes your username, and then you run it on a different developer's machine that has a different user home directory, that might cause a cache miss if you're using the fully qualified path to a file as an input. So the way that we understand if these things are happening is using a feature in Gradle Enterprise called the task input comparison. If you run two identical builds, you can then compare them using the UI. And this is how you do that in the UI, how you compare two builds, highlight them and click the Venn diagram, and then you see all the differences to the inputs. So let's take a look at what some of those differences to the inputs might be.
Okay, let's go to the top 10 of this year. Not 10, but well. So we are going to start with one easy, and it's related to the differences in the configuration for CI and local environments. So you can spot these kind of differences because we have a difference in the incremental compilation for the Kotlin compiler. And the origin for this problem is just that we are using a different Gradle properties for CI, for local, and one of the Kotlin incremental properties is different. So it's okay, totally okay, to have different values for the heap memory in terms of CI and local, but for properties that they are going to be related to one input of one specific task, we can have these problems. The same applies to when we are using configurations in CI and local using arguments in the built invocation. So you can pass some arguments, and then one of these arguments is going to be considered as property for all warnings errors, in this case for the Kotlin compiler. So we know that sometimes we want to keep this configuration, but the recommendation is always trying to keep the consistency between CI and local, because if not, you are going to generate a cache miss. The next one is, well, we call live literals, but it's related to compose. So we can say that we are seeing more companies and more projects using compose. And one thing that we have seen in some of our customers is Java compile cache miss with the properties, with the class path, for some classes appending the live literals on the classes, on the bytecode. And what's that? So if you're working with Compose, so you know that when you're working with your composable functions, Android Studio allows to have like these quick iteration cycles where you're going to see the change on the emulator, right? And this is the feature that we are, it's called live edit, I guess. Well, you know better than me. But sadly, this feature is producing these live literals problems when we are building, when we are comparing builds from CI to local or from different paths. The immediate fix here is to disable.
And just to clarify, the reason it's happening is it's writing the absolute paths into the class files.
Okay, okay. Got it. Perfect. So the immediate solution here is to disable the feature. And we have different opinions here. So if your company is still in the early stages in the adoption of Compose, that's okay to disable. But we have seen that other companies, they are relying a lot of Compose, and they don't want to disable the live literal option. So in that case, there is an issue on the Google Tracker. Please start it and follow up, because this is something that is going to affect your Java compile task sooner or later. Perfect. So the next one is about KSP. As well, we are very happy to see that the KSP is becoming more and more involved in the Android development. Recently, we have seen that one of the major dependency injection frameworks drops one comment about a possible roadmap related to KSP. So to KSP. So that means that, well, we hope that the adoption of KSP is going to be massive. So KSP is the Kotlin symbol processor, and is much faster than CAP, the Kotlin annotation processor. This cache miss is related to the plugin options of the KSP task. And that's something that is coming in this case from one module that was using the room processor. The room processor can use CAP or can use KSP. And we're very happy to see the current recommendations from Google, where Google was, this is official, this is like in the doc, where they are configuring the KSP extension with a command line provider argument. Actually, Nelson, you merged the PR, right, for the command line argument providers in KSP. So and that's the correct way to do that, right? And even they are using the proper information about the path sensitivity. That's one of the common problems that we saw in the past with Room. But even with the correct approach provided by Google, we were still seeing this problem. So when we were building from CI and then from local, a task difference for the plugin options was generated. So we investigated deeper the KSP. And what we saw, well, internally, KSP is using sub-plugin options as internal. Internal means that is not going to be considered for up-to-date of cacheability. So that's something that you can declare your task with this annotation, and this annotation means that, well, it doesn't matter. And later, in the code of KSP, we were seeing that we were using these internal properties to add sub-plugin options on the Kotlin Gradle plugin. So the Kotlin Gradle plugin keeps another internal annotation for the sub-plugin options, and later, what it's doing is creating an input of a property for the task. And something didn't sound right, because from an internal, we were passing an input, and actually, this is the one that is failing. And what we saw is that, well, in this case, we are not considering the path sensitivity of KSP in the Kotlin Gradle plugin. That's why, if you are using KSP and you are using the room processor, you're going to have this problem when you are comparing CI and local, or local with different locations. We raised an issue, we create a PR in KSP, we merged it. The fix was to replace the sub-plugin option by internal sub-plugin option, and we are hoping to have soon, well, a KSP release soon. So stay alert, because once it's fixed, this problem will be done. Perfect. So the next one is about the Java compiler again. So the Java compiler, so when we are seeing like this problem is when we have differences in one of the specific outputs that's called transform output for the JDK image. So actually this was very bad because it was always breaking the Java compilation. And let me put you a little bit of context. Since undergraduate plugin 7, when you have source compatibility 9, the undergraduate plugin is going to apply transformation on the JDK runtime. Why? Because at the end of the day, you don't need everything of the JDK, right? So you only need the classes that they are relevant to the Android or component. Later, once the undergraduate plugin has stripped this Java runtime, is going to be included as compiler argument provider. So far, so good. If you have the same Java version, the same vendor, that means that you are going to generate the same transformed output. But when you have some differences, we have seen that the output was different. So we created an issue, and in our plugin that is called Android Cache Fix Gradle plugin, thanks to our colleague Gary, we fixed this problem. This problem was fixed by normalizing the small differences that we were having in the SDK. So the issue Google mentioned that was fixed on 7.4. So we drop the compatibility of the plugin, or we drop the workaround for the version 7.4, and I think it was like 4 hours that later one user created a ticket for us. So the issue was not fixed, we thought, right? We pinged Google, and Google mentioned, yeah, it's fixed, so I don't know what's going on. In this case, we started a complete investigation. So the first thing that we did was create a compatibility matrix between different versions. We started with JDK 17, and actually, since version 17.02, this issue was fixed. So we don't require workaround, we don't require to do anything else. But if you are working with 17.02, this issue is present. So the user that was reporting this problem, he had very bad luck because he was using 7.02, and this was the problem. But actually, JDK 19, JDK 17, so far so good. Well, and remember that JDK 17 is required for undergraduate plugin 8, so I think that most of you are okay. Then we compare JDK 11. So JDK 11, as you can see, is totally mess, right? So a lot of different misses when we were comparing different versions. And yeah, so in that case, we can apply one technique that is called, to fix this problem, that's called normalization. So Gradle, by default, apply normalization when to understand that the zip APK, a jar file, is the same independent of small differences, like the timestamp, like the file ordering, right? That's what is called normalization. But we can extend this normalization and apply our own runtime normalization. So the first thing that we need to do to fix this problem is to compare the outputs. To do that, we need just to grab the CI, in case that one of the sources is CI. We need to grab the jar from CI and the jar from local. And then we need to compare both outputs. So you can use your favorite tool, diffoscope, right? So diff. But in my case, I'm using IntelliJ to compare different outputs. And you can see here that actually there is a small difference in the implementation between two different JDK vendors. I don't know why, and we don't know, right? But there is a small difference. Because this is an internal Java class, we are OK applying a normalization with that. And don't be scared. Applying the runtime normalization is quite simple. To all projects, we declare the normalization. And finally, we specify the path of the elements that we want to ignore. And with this approach, we are fixing the problem entirely. But just remember that JDK 17 is up to date, I would say, and JDK 11 still is struggling, but we have this technique. OK, the next cache miss that we are seeing often is the observability components. By observability components, I mean Firebase, I mean Embrace, I mean New Relic. And we need these tools, right, in our commercial Android apps. And the cache miss is coming from one of the value properties have a different property. That's totally fine, because in this case, New Relic requires to create a session, right, for every APK. So, but the problem is, like, because we have this difference, we are affecting the Java compiler task. So our problem, no, not our problem, right? But here the complexity is not like in KSP or the undergraduate plugin that we can create plugins because these libraries are private, and that's totally fine. But we don't have, well, the flexibility to say, hey, so something is wrong here, or they have their own policies, and they want to keep always keeping this configuration. So that's something that we need to check the doc. And the doc sometimes said, hey, if you want to disable the instrumentation, you need to apply that. But this is only for the instrumentation, not for the generation of a single ID for each build. And we have seen different solutions from customers. One of them is apply conditional logic in your build scripts, applying or not the New Relic plugin in this case. So imagine that you are in debug or you are in your local build, so you don't want to apply the plugin because at the end of the day, you are working locally on incremental builds, cycles, so you don't need to generate an APK that you want to send to metrics about anything. So one of the options is trying to apply this plugin conditionally, but we want to offer another possibility using the Android variants API that we are going to directly to disable the New Relic config task configuration, disabling the task itself. And when we execute one experiment or when we compare different builds, we don't have differences, so this approach works, and we are just mentioning different approaches. Okay, so next one, it's about task implementation chains. I think that we are seeing a lot of this issue, and well, we want to give an explanation as well, because sometimes it's a little bit difficult to understand and could be overwhelming because, well, apparently everything is the same, but it's not the same. So one way to identify this issue is when we are hovering over the Kotlin compile, we are going to see a small pop-up saying task implementation chains. And well, chains of what, right? We can replicate if you are not using Gradle Enterprise. When you add or Gradle caching debug true, you will see that the implementation of the task is different. What is more confusing is that the build scan comparison is giving more differences in different inputs, like the compiler option, like the Kotlin Java toolchain provider. What's going on? So it's a task implementation change, but we have different value properties. And what is worse, so this is not affecting only one plugin. This is, in this case, we can see that we have task implementation change for the Kotlin Gradle plugin, for the Android Gradle plugin. So something is going on. So the first thing that always comparison, the dependencies are the same. The build dependencies are the same. And when we compare the JDK, it's still the same. So in terms of the build class path, we have same Kotlin Gradle plugin, same Android Gradle plugin, same JDK, same dependencies, but still, there is something that is generating a different build cache key for all the tasks. So this is the worst case that you are going to find. Let me first talk about version catalogs. That's how we are centralizing the versions in our projects by Gradle, right? So we are using like different blocks on the TOML file or in the settings.gradle, where we are specifying a version and we are specifying a library. So later in our code, what we are going to do is access by default these dependencies that we are defining in the version catalogs. So, and it's like safe accessors, right? That means that we can have autocomplete, highlighting, and so on of the IDE. But let me tell you more about this feature. So if you explore the .gradle folder of your project, you will see that for your current Gradle version, you have one folder called dependencies accessors. This version, this folder has different entries represented by a hash. And as you see, we have sources and classes. If we click in one of the sources, what we are going to see is that we have the dependencies that we have defined in our version catalogs. So for each entry or for each dependency and version, we are going to have a different accessor. And what we have seen is like what we have seen in some cases is that the manipulation of these version catalogs is generating different hashes for the dependency accessors. And this element belongs to the build class path, and that means that we have a difference. So in this case, we have reviewed the different actions that we can do in a version in a TOML file, and those are the ones that they are going to generate a different new dependencies accessors key. So if you're working locally and you add a new library, you are going to generate a new dependencies accessors key. So keep in mind that, because instead of wasting a lot of time, that's something that you need to understand, and as well, something that is applied for the type safe, project type safe accessors. That's another feature from Gradle, and just check it out. My recommendation, if you're suspecting that you have this problem, remove your project.gradle folder and execute the build again and compare. If works, that was like the problem.
All right, so we talked a lot about build cache misses, and now we're going to talk about configuration cache misses, which are even more exciting. So I don't know if you've ever seen this message in your build. I know everyone here is a hawk and examines every single line of their console log on every single build. But if you've noticed this message, that means that the configuration cache couldn't be reused. There could be many reasons for this. In this case, we're going to examine a very specific instance of it happening when this was the message. So yeah, how do you debug this? So your first instinct would be to check the configuration cache report. And you look at it, and well, there's no issues in the configuration cache report. Well, yeah, there are no issues. We were able to generate a configuration cache entry. What we're trying to understand here is a configuration cache miss. And so there's no built-in way, actually, of debugging this. So what you have to do is attach a debugger to the Gradle build process. This is how you do that. You set a breakpoint in the configuration cache fingerprint writer and the configuration cache fingerprint checker, and then you print the files that are changing. So in this specific case, what we saw is this folder, build / generated source cap debug, was being read at configuration time. And this was only happening in Gradle 8.1. Why is that? So Gradle 8.1 included configuration inputs detection improvements. Actually, every single new version of Gradle since the configuration cache was introduced added input detection improvements. That means basically every new version of Gradle is detecting more inputs to the configuration cache. That's one of the reasons why the configuration cache was not considered stable before 8.1. And if you look at the release notes, because I know everyone here reads every single line of all the release notes, it says, we now detect file collections being queried at configuration time. Here's a link to the release notes in case you want to read up on it later. So what was happening before was we were actually reading this file at configuration time, but Gradle wasn't detecting it as a difference to the configuration cache key. And so yeah, putting together a reproducer, basically any time that you're using capt with the Android Gradle plugin and Gradle 8.1 or higher, you will have a configuration cache miss on your second build. So it's actually pretty easy to reproduce. You just apply capt. So we filed a bug for it. We caught this because we run regression tests with configuration cache for our Android cache fix plugin. And when we updated to Gradle 8.1, our configuration cache test failed. So yeah, we filed it against JetBrains, and they said it was fixed in Kotlin 1.9. We checked it with Kotlin 1.9. It actually wasn't fixed, so we filed it again. Then it actually is an issue in the Android Gradle plugin. So that'll be fixed, hopefully, in Android Gradle plugin 8.2. Cross the fingers. All right. Next, going back to regular cache miss issues, debugging task inputs. So yeah, away from configuration cache, in case I confused everyone with that. I just want to introduce a strategy for debugging task inputs using Gradle Enterprise. So going back to the cache miss with KSP that we were looking at earlier, we have a difference to the plugin options, as Inaki mentioned. So basically, this is the field that we want to look at on the KSP task JVM. There's a plugin option and the input arguments to that. So how do we understand what that value is so we know more about what we need to do? So what we need to do is configure the KSP task JVM. This is how you configure a task in Gradle. Then what you want to do is add an action, a do last action in this case. Now you don't want to print inputs and outputs. This is just a debugging tip during the configuration phase, because the inputs and outputs could change from other task actions and other configuration phase things that are happening between the configuration phase and the time the task executes. So you should print inputs in either the do last action or the do first. You can print them to the console, but I'm going to show you another trick, which is to add them as build scan values. So let's grab the plugin options on the task, call get on it, iterate through that list because there's the $0. And then on that list, we're going to grab the task input args, that's function, and then what we're going to do is add them as build scan values. It's as easy as that. And yeah, you have to call root project. That's just a quirk of printing build scan values. So yeah, this is how you print them, and then what does it look like? When you do the task input comparison in Gradle Enterprise, you get those values. And here you can see that to the KSP, AP options, annotation processor options, we have the fully qualified path, which is different. So these are those fully qualified paths that are inputs that are causing issues. All right. I think we should skip this part just because of time. We recommend the build validation scripts to test things. But what I'm really excited to tell everyone about is kind of a different thing from our presentation, but it's about artifact transforms. And yeah, before I explain what I wanted to explain, what are artifact transforms? In case you're not familiar, it's a concept from dependency management in the Gradle build tool. And what it is it changes a dependency from the incorrect format to the requested format via artifact transforms. So for example, in an Android build, you would change a classes jar into a dex file, or a dex file into a classes jar, or a jar file into a set of class files. Users or build script authors do not directly request transforms. Basically, you register a transform, and then Gradle schedules transforms between units of work, such as tasks or other transforms. And transforms can depend on tasks, and they can also depend on transforms. So that's a little overview of artifact transforms. And Android builds use a lot of artifact transforms for dexing, for Jetifier, for things like this. And what I want to tell you is that artifact transforms are now visible in build scans. This is actually one of the most commonly requested features from the Android community. So we're really excited. I will add a caveat though. You have to use Gradle Enterprise 2023.1 and the Gradle Enterprise Gradle plugin 3.13 and the Gradle build tool 8.1, which, as I mentioned earlier, has an issue with configuration cache misses. And for now, it only visualizes project artifact transformations, but it's a really cool feature. So I'm just going to show you a little bit of what it looks like in the build scans. So this is a build scan on the timeline page, and in addition to seeing tasks, you now see transforms as units of work. You can see that listed in the page. This is a transform, the other ones are tasks, and you can see the duration. You can then click on that artifact transform and get even more details on it. You can see the source and the target of that transformation. For example, this is a transformation from an instrumented jar to a dex file, and you can see, yeah, duration. So why is this important in build scans? One, it's to understand what transform dependencies are being run in your build, understand gaps in the timeline, and also understanding artifact transform errors. And I'm going to demonstrate what that looks like. So understanding transform dependencies. So if you click on an artifact transform in a build scan, you can click the predecessors tab and see the dependencies of that artifact transform. And also for tasks, you can see the artifact transforms that that task depended on. So when you're looking at why did a task take until this moment in my timeline to start running, you can now see that, oh, it needed this transform to run before it could start executing. Which leads me to my next point. This now fills a lot of gaps that used to be present in the timeline. So this is the timeline, and all the light blue spaces are artifact transforms. These used to just be empty holes in your timeline, and now they're filled. Also, you can filter by failures in the timeline. And then you can view artifact transform failures in the failures tab, which also means they're available in the failures dashboard in Gradle Enterprise. Yeah, there's more work to be done. So right now, you don't see whether artifact transforms are cacheable in build scans. That's something we're working on, of course, and up-to-date checks. We're working on improving the filters in the timeline, and then also supporting more transform types. So for example, right now the Jetafire transforms are not visible. All right, yeah, I just wanted to highlight there's more Gradle talks at this DroidCon. There were a bunch today. The only one left is Armas's talk tomorrow at 11:25 in Fisher West about profiling and optimizing builds. If you're curious more about Gradle Enterprise, you can do a Gradle Enterprise trial. If you want to learn more about Gradle, I highly recommend the trainings. Our new trainer, Akshay, is doing some really, really good trainings that I even learned stuff with, and they're really engaging. So I really recommend signing up for them. They're completely free. And that's it. Thank you very much.